Welcome to the Astro. So in this Python tutorial, we'll be reading and plotting data cube. Okay, so data cube used in astronomy are basically your say you have three data axes x, y, and z. So x, y axis data contains your image, and z axis contains your wavelength range. Okay, so basically you can see in the image it's like a data cube or your Rubik's cube, which has like 3 cross 3 uh, matrix, and you can see that the z-axis is extended in three parts. So basically, data cubes comes in say xyz format. So xy basically x cross y cross z. Okay, so x cross y is basically your image dimension in that your face, and z dimension is your wavelength range. Okay, so we'll try to read a data cube from MAMGA, and we'll plot its image at a single wavelength, and also we'll plot its spectra for a single spectral in the whole wavelength range. So let's do it. Okay, so for doing that, for doing data cube, first import some libraries. So import libraries. Okay, so first we will import numpy. So import numpy as np. So it will um, deals with array and array operations, and then we'll import matplotlib dot pyplot as plt. So this deals with plotting. So this deals with plotting, and then we'll import our spec utils library to read data cube. Okay, so from spec utils dot spectra import a spectrum 1D. So basically 1D makes um, your your data as a vector. So this is deals your fits cube. Now this much we have done. Now we'll read data cube. Okay, so let me add a cell here, and then you can give your file name. Okay, so you can give my file name or file equal to. So in my directory there's a file called MAMGA. So I have a MAMGA. I have this cube, and give a file name. Okay, so if you print file, you can see it's contain this file name. Now, so this is my file name. File name data cube. File name of data cube. Now read the data cube. Okay, so read data cube. So for that, d underscore cube equal to a spectrum on d dot read and pass your file variable. Okay, run it. There is some error, but ignore it. Now see what your d cube is. So you can see it contains the flux as a vector quantity, and then you have uncertainty, and then we have a spectral axis. So this is like your two-dimensional image for flux at every spectral, and this is your spectral axis. So now this much you have done. Now we'll check the what is the shape of the data cube. Okay, so check shape of data cube. So for that type here np dot shape and can pass your d cube, run it. So you can see that your data cube has 34 into 34 into 4563 axis. So 34 was the spatial size. So 34 into 34 is a spatial size, and 4563 is wavelength axis. Okay, now you can extract your flux and other stuff. So flux is in your like xy column, right? So for that, okay, this much we have now extract the flux. Okay, so here extract flux at a spatial, say here xy such that 17 into 70 x pixel. So total we have like 34 to 34. So we'll find a midway how the image looks like, right? Maybe okay. So we are going flux at a spatial xy at 70 comma 17, right? So you can give here say a spec equal to your d cube and 17 comma 17, and you want to take your whole wavelength axis. Okay, now type here plt dot plot. So you want to get your a spec dot your spectral axis from here. So compute, and so this become an axis. Now you want to obtain your flux. Okay, type here spec dot flux. Now run it. So here you can see that you have plotted your spectra at 17 comma 17. Temporal dot show, and here plt dot figure. Now it's fine. Okay, so this spectra is at 17 comma 70 as pixel, right? So you can change it, and you can see spectra will changed 18 comma 18. Now you can 1 comma 18, you can say it's a no, it's blank, it's blank. So you can change all up to this range. Okay, I think that will be 33 because in Python 0 is 1. Okay, so I will put it at 17 comma 17, right? Can give a title here, label equal to your spectra 17 17. Type here plt dot legend. Now this is our file. Okay, you can like also get your wavelength and your flux unit. So flux unit is this one, and below the axis in the meter. Okay, this is in the meter, right? So you can get it. So for doing that, import here unit called import astropy dot units as u, right? And then you want to give your axis, right? So for doing that, you need to label your x and y axis, right? So you can type here plt dot x label. So x label is your x dot your spec dot flux dot unit, right? There should be a spec. So you got here there should be y. Okay, so y should be that. So this is a flux unit, and similarly you want to give your x unit plt dot x label. So you want to give your spectral axis and pass your unit. So this become your meter. Okay, so this step is done. We have plotted spectra at any xy position. So for time being, I have plotted spectra at only 70%. You can also like extract a spectra in the between. So I want to go between 2000 to 35. So spectra is sliced, right? 1, 2, go up to 3. This way you can also extract your spectra, but for time being I will like do the full spectra. Okay, now so we have done a spectra of plotting at a single spectral. Now I want to plot the image at a particular wavelength of the galaxy at say lambda equal to 3800 angstrom or 38 I mean in the meter. Okay, so for doing that, type here plt dot, or maybe you can type here image equal to d cube, and you want to leave your spectral as usual, and you want to uh, plot image. Okay, image at say 3000. Now type here, so this has extracted image at single wavelength. Now plot it. Okay, for that type here plt dot m. Okay, this is like your 2D image. Okay, so you have to show it using image show, and then pass your image. Now run it. What is the mistake? Okay, so you have to find your flux. Okay, so for that give your image dot flux. Okay, so here you can see that you got your image at this particular wavelength, right? You can also make to, so image will change. Okay, so at every wavelength the image will be changed. So this way you can append your image at any particular wavelength, right? So basically your x and x levels are here. You can say it x, so basically say a spectral, and yx is also a spectral, and plt dot title you can give, it is your image at any wavelength. So this way we have done our job successfully. So we have read the fits file, I mean fits data cube, and we have check its a shape. Okay, so we have 34 cross 34 into 4563 wavelength, and we have plotted image at a single wavelength, and then we have plotted a spectra at a particular spectral xy. So it